All right, in skill 3, we're going to look at the derivatives of an exponential function where the base isn't e, and logarithmic functions where the base isn't e as well. So just to keep track of what we've got so far, we've got if y is e to the x, y primed is e to the x. If y is a log base e of x, the natural logarithm of x, y primed is 1 over x. So that's what we've got so far. And what we're going to add to that is if y is b to the x, what's y primed? And if y is log base b of x, what's y prime? And if you kind of remember, when we were doing skill 1, how we got to e is we figured out that for 2 to the x, it was like 0.69 times 2 to the x was the derivative. And 3 to the x was like 1.1 times 3 to the x, so there's some constant in front, and we got to figure out now what that constant actually is. So the way you do that, so I'm going to start with y equals b to the x, and we did first principles and we kind of got stuck and we had to use some estimation to get to what those constants were. So we're going to go a different way. Now we have something that looks like this function. We've got e to the x. So what we can do is we can actually write b to the x as a base e, and the trick is you do e to the log of b to the x. So that looks kind of crazy, but it's just playing off the fact that e and log are inverse functions. If you do one inverse and then the other, if you do the function and then its inverse, you should get back to where you started. Just like if you square root and then you square, you'll get right back to where you started. If you log and then you put it to an exponent, you'll get right back to where you started. This says give me the exponent on e with this as an answer. It's taking whatever that crazy exponent is and putting it on e again, so the answer is still this. So we haven't changed the function here. So now what we're going to do is use that nice exponent rule, logarithmic rule, where the exponent kind of floats out front of the logarithm. And what we're left with, really, is the natural logarithm of b, and remember b is just going to be a number. It's going to be a 2, it's going to be a 3. So that's just a number times x. So there's no problem there. We can do the derivative here. The derivative of e to a function is e. You leave the function in the exponent, and then separately you multiply by the natural logarithm of the base. And then what I'm going to do is just, this here is still the same as this, which is still the same as this. So I'm going to write this as e log of b to the x times the log of b, which is again just a number. And e to the log of b to the x is just b to the x. So you end up with the log of b, I'm going to write that out front because it's the constant, times b to the x. So this piece is just b to the x. It's the same as this, which is the same as this. And we have our first formula, the log of b times b to the x. So that constant out front is the natural logarithm of the base. So if you go to your calculator and hit the natural logarithm of 2, we'll get the exact answer of what that 0.69 is, and it's 0.693147118, blah, 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 probably. So that's the constant out front, and the natural log of 3 is 1.0986122289 on my calculator. So that's what this constant is supposed to be that we were estimating when we were trying that limit out. So there's our new formula. So it's sort of nice to, I like seeing these formulas side by side. E to the x is just e to the x. B to the x is b to the x, but you do the natural log of b in front. So it's kind of they're kind of related. In fact, if the base was e, this would be the natural logarithm of e. Log base e of e would just be 1. So that wouldn't b. That's why it's just e to the x. That's kind of the point there. So now let's go the other way. So we're going to get our other formula, log base b of x. And again, we want to change it to log base e instead because we have a formula for that. So I'm going to use my change of base formula, which works for any base. So I'm going to change it to base e. You do the base you want of the old argument, and then you divide by the log of the base you want of the old base. So that's the same again if you're doing log base 5 of 100. On your calculator, you'd hit log 100 over log 5 is what Marshallin would have showed you to change the base there. But that works with absolutely any base, so you don't need to use log. You could use the ln button on your calculator. You'll get the same answer. So I'm just using that kind of formula to change to a base that I know. And that's just, again, some constant times a function that we know how to do the derivative of. So 1 over the natural log of b is just some constant. So now if I do the derivative, think of this as like a 2 or whatever, it's just going to stay out front. And we're going to multiply by the derivative of the natural log of x, which is 1 over x, and 1 over log base b of x. And there's our second formula. So if it's a different base than e, it still kind of looks like 1 over x, but there's the natural log of the base in front. And that's why I like looking at these formulas side by side, because the only adjustment is the same adjustment both times. You're putting a log base b out front of the old thing, a log base b out front of the x. So instead of 1 over x, there's a log base b in front of the x. So you just got to remember it's in the denominator on that one. So those are your new formulas. So let's see if you can make them work. See if you can get these 4 derivatives here. You can pause and try them and then check my answers and see how you did. And then that's all we got for this lesson. So try and make it happen. So for this first one here, 3 to the x, the new formula says you do log of 3 times 3. This would be to the x. Instead of x, we have a function, so we leave that function there. This is the chain rule happening. And then completely separately multiply by the derivative of that function. So that's what that should look like. This one here, another chain rule. I'll switch colors. The 4 drops down, becomes a 3, the log stays inside, and then completely separately, we're going to do the derivative of that log function. So derivative of log is 1 over the natural log of the base. So when they write just log, they're talking about base 10, so natural log of 10. Normally this would be x, but instead of x, we have a function, so we leave that function there. And then the chain rule says completely separately multiply by the derivative of that function. So the derivative of that function is 3. So the derivative of 3x plus 1 is all I'm looking at there. Next one down here, we've got 2 things multiplied together, so I'm going to call one of them f and one of them g. F prime, so the derivative of 2 to the x is log of 2 times 2 to the x, but instead of x we have a function, and then the chain rule says multiply by the derivative of that function. G primed is going to look kind of the same. 3 to the x is log base e of 3, natural log of 3, times 3 to the normally just x, but we've got a function, so you put that function there, and then you multiply by that function's derivative. And then I'll put it all together down here. So my overall derivative is f primed, so log base 2, 2 to the 4x times 4, times g, 3 to the 6x, plus g primed, well, 3a 6x times 6, times f to the 4x. So there's my f prime g plus g primed f. All right, and jumping over to D. Oh, this one looks annoying. So we've got log base 2 of a function. So our derivative of log base 2 is 1 over the natural log of 2. Normally x, but instead of x, we have a function. And now separately, we have to do the derivative of that function. So we got to do the derivative of that piece there now. So the derivative of 3 to the x is, ooh, I don't want to write in a highlighter. That'll be annoying to log base 3 of 3 to the, normally just x, but we've got a function. And since that's a function, we need the chain rule one more time. Derivative of that function is 2x. So I think we got it there. So consolidation, just making note of what the new formulas are and how they kind of work. And then you can try the exit, so 3 more for you to try that we can take up when we're in class. And then the practice, again, that'll happen in class as well.